All right, this is going to address 3.6 inverse functions. So inverse functions is a concept of which all you're doing is basically switching x and y. So the inverse of xy then becomes yx. So all coordinate points of any system of inverse must be able to satisfy this condition. So if you were to take and graph a function, let's say this was a function, all right, I'm just making something up right now, all right, then I would go ahead and inverse that by simply just taking coordinate points that this thing goes through. For example, let's just make sure that we say that this is the coordinate point here, that the inverse of that would be then here, all right, where this is, it used to be, when we look at this 2, 0, it now becomes negative because we're flipping it, and it becomes 0. Well, that's negative, by the way. And then it becomes 0, -2. Okay. So we have the inverse. And then what we do is take any coordinate point that lies on this particular function and reverse the coordinate points of x and y, and it becomes the opposite. So we now could do that. We can graphic. All right. So, and it follows along this, what we call identity function, where it reflects over this particular line. So when we are doing this, all right, there's a couple other different things. We talk about a one-to-one relationship of the function, all right? Now, the function itself has to, in fact, be a function in order to reside as a one-to-one relationship. So this fails, and what we use is a horizontal line test to determine whether the function itself is going to be a function once we take the inverse of it. So it basically, this one fails the horizontal line test, but this one fails to be even a function because it's not a function through the vertical line test, so we throw it out. This fails the horizontal line test. This passes the horizontal line test and passes the vertical line test, so this is one of our answers. This fails the horizontal line test, and this passes the vertical and horizontal line tests. So we have our answers. Okay, and that's as much as we need to worry about in that regard. Okay, 1 of 1. So we keep on doing that through this process. Okay, and I would like to go ahead and continue this through just going through and seeing that this fails the horizontal line test. This passes the horizontal line test and passes to be a function, and then this is going to go ahead and fail the horizontal line test, so that's not it. This is going to pass. This will pass both parameters, so we have our answer. So this moves very quickly. Okay, so I got something, I must have gone too fast, but let me double check. All right, this right here should look good. All right, I don't see how this, excuse me, I didn't mean to do that. How this is, I'm having errors here. What the heck? I'm going to go ahead and quickly show you. All right, I'm having issues. Okay, so here's the answers that are there, and that's what I gave. It's having technical problems. Okay, so I didn't put that answer. Okay, so that one is obviously it too. I'm going through this too quickly, but that one is going to suffice as a passing of a horizontal line test and be a function. So now when we're looking at a relationship, then, all right, which of the following function is not a one-to-one relationship? Then we see that the 1 and 1 is repeated for the outputs. So then that fails the horizontal line test. So then that would be our answer for that one. Okay. So then when we say which select all the following tables which represent a one-to-one function, we're looking at this one failing, okay, because this has repeated outputs. And then this one passes, this one passes, this one fails because the 16s are repeated. So the answers are going to be this one and this one. And that's what it shows. All right. Now, when we look at this, all right, the answers are going to be L, X, or, X and Z. So X, L, and Z, G and M are not one-to-one relationship. And looking at it, we can see that if we carefully look at it, there's a repeated, no, not for that one, this one. There's repeated -1 here, all right? And if we look at this one, there's a repeated value system of 3 and 3. So we're looking at that one right there, okay? So we have 3 and 3. So that's where this comes into play, okay? So you got to realize that it fails to be a function itself, therefore fails to be a one-to-one relationship. All right, now when we want to go ahead and restrict this, if we were to if this is going to fail the horizontal line test, but what about if we cut it right in the middle? We cut it in half. Then it would go ahead and restrict the domain so that way we pass the vertical line test. So we can either choose left side or right side. So choosing left side, we're going to go ahead and have -infinity to 0. All right, that would pass the vertical line test and horizontal line test and such. All right, and then we have the 0 to infinity would also allow this to pass the vertical line test and horizontal line test. Mainly, preferably, the horizontal line test in this, okay, because it is a function. So that's the restriction that we'd have to put on this in order for it to pass the inverse check. All right, now when we're going ahead and determine whether or not the graphs are, representing inverse, all we have to do is think about, are the coordinate points doing in fact this? And they are, as you can see. We can choose a couple points like this one and this one. All right, this is coordinate point 1, 4. This is coordinate point 4, 1. So therefore, these are in fact inverses of each other. So these two are representing an inverse function. Likewise, the same thing occurs for this one. If we go ahead and draw a diagonal, the identity function, then we would go ahead and see that the coordinate points on this one would be in fact coordinate points on this one, and we would have the inverse function. So this does represent a pair of inverse functions. Whereas this one, if we were to draw that line, we would not be falling upon itself. Real quick, we can see that. So this one would be not a representation of two functions that are inverse of each other. Now they want us to go ahead and graph inverse functions. So all you do is choose what 2 points create an inverse function. So this one is 0, 1, and then this is -2, 0. So all you got to do is go ahead and graph those 2 coordinate points by going ahead and reversing it. So it would be 0, -2, and then it'd be 1, 0. So that would be the answer that we're looking for in respects to graphing the functions. Okay. Now you do the same kind of concept for this, right? So you go ahead and graph the coordinate function, but they're asking you to determine the domain and range. Now the domain is all values of x, so it's going to be from -infinity all the way up to 0. So that would be our domain. And then the range is from -6 on into infinity. Now the inverse function is just, again, switching that value system. So the way to look at it, it goes from -6. So we're going to put a coordinate point at -6 here on the x. And then looking at it, we would go from -6 to what value system? Here's one at -2, -2. So we're going to go at +2, +2. And then we're going to go ahead and state that the domain is from -6 to infinity, and it's inclusive. All right, and its range is from 0 to infinity, inclusive. Okay. I apologize. Let me see. No. How does that work? Oh, we have this coordinate point, the inverse of the, oh, I put it on the wrong side, of course. It's over here. Wait a second. Okay, so it was -2, -2. Oh, you switch those two, it would be still -2, -2. Oh, darn it, that's my bad. So yeah, it reflects over that line. So my bad. Yeah, I'm glad to look at it and be able to. So you're reflecting. It's not that you switch the signs or anything. You just switch the darn coordinate points, and you get your answer. So I went too fast on that one. Sorry about that. So of course, -2 stays -2, and that's why we get the value system from -infinity all the way up to 0. All right. So we're going to go ahead and see that that's in fact the graph. I apologize. My bad. Okay, so yeah. So all we're doing is switching the coordinate points. I'm kind of going through this quickly because it is pretty easy. It's just a matter of being able to determine what are the switches. So slowing it down a little bit, if this is -1, -2, then it becomes -2, -1. So you put a point here. This is 5, 0, so that becomes 0, 5. So you're just switching the coordinate points. So now, when it comes down to the domain of this one, the domain is from -3 up to, but not including 7. So that would be our answer for that one. The range would be from -4 up to 6, but not inclusive to the 6. All right, because there's an open circle at that value. And then you find the coordinates of the graph by doing what I said. So you switch the signs, or switch not signs, but switch the coordinate points, and you go ahead and get these values right here. Okay. Now, whenever you have a 7 and 7, like this one was, I think it was 7 and 7. Oh no, it was 6. Okay, it was 7, 6. Then you would switch it from to 6, 7, and that would be where you put that coordinate point. All right. Now make sure you put open circle, closed circle, and such things as that. So at that value system, we would go ahead and put 6, 7. We would get our open circle. All right, because it was 7, 6. Now we need to put it at 6, 7. So that's why the answer falls on there. All right, and then you put a closed dot at the value of here, and then you put a line. You draw a line segment from here to here. All right, I mean, that's pretty simple. And then you do the same thing for the next part. All right, remembering all you got to do is switch X and Y. All right, and slowing it down a little bit. Don't go as fast as I'm going. I just want you to make sure you understand that all you're doing is switching points. So right here, the next one, that being -1, -2, I'm going to switch to -2, -1, put that here, put a line segment from here to there, and then I'm going to go ahead and switch the coordinate point from -3, -4 to -4. Where is mine? -4. Excuse me. -4, -3. All right. Oh, I need a dot. And then put a line segment. And then you would get the same exact value system that we have here. Okay. Now the domain would be from -4 to 6 exclusive for the 6, and then it would go from -3 up to 7. Now take note, and this thing's going a little slow. Take note of these two value systems and see how they're different from this one. Look at this one. This one's -3, 7, -4, 6. This one's -4, 6, -3, 7. So the domain and range are switching, aren't they? Because we're switching the X and the Y. Wouldn't domain and range switch as well then? I mean, something to think about, okay? All right, so when we're looking at this right here, okay, they're saying to go ahead and to graph the logarithmic function f is given below. We will soon discuss the graphs in great detail. the inverse function of a logarithm is an exponential function. Again, more of both functions soon. So those are going to come in later on in chapter 5. Okay. Now, using the two given reference points, sketch the graph of the given function f and its inverse along with the identity function y equals x. So if we're going to go ahead and do that, we're going to go ahead and graph this first. All right. And we're going to go ahead and graph the coordinate points of 1, -4. And make sure we graph the next one, which is 3, -5. All right. Now, we're going to have to make sure to graph this properly. All right. We want to, hold on, get this. Okay, this is a, let me see, I got to do this first. Okay, so this is a logarithmic function, so I'm going to go ahead and graph that one first. It's not giving me what I need. I got to make it, I got to force it into that situation, don't I? So then I got to go put it at 3, -5. Now I want to go ahead and graph the inverse function. So I want to go ahead and switch those components. So 1, -4 becomes -4, 1. And then I want to go ahead and graph the next coordinate point, which was 3, -5. I want it to be -5, 3. All right. And they look like they're, if you tilt your head, they look identical to each other. If I take all this and flip it over on top of itself, if I was to fold along the identity function. Now I want to go ahead and graph the identity function, and that is that line right there. And it starts to look like a cool looking graph. I mean, but that would be our answer we're looking for. Okay, 1 to 1, 1 of 1, excuse me. So I've answered all those questions properly, and I graphed it. Now, if we notice then right here that the domain of f of -1 is -1 or whatever, it's just function notation for inverse. All right, the domain becomes the range, so it's going to become -6, 15, and then the range becomes the domain of this coordinate point. All right. Now, if the point 23 lies on the graph, then the point 320 is guaranteed to be lying on its graph of the inverse. Now, if the point 14, -8 lies on the inverse, then -8, 14 is guaranteed to lie on the graph of the function. Now, to summarize, the domain of f is equal to the range of the inverse, and the range of the f is equal to the domain of the inverse. All right, so that's how that works. Now, we could determine inverse functions by using the composite function naturality. All right, so we talked about the nature of the fog and golf is that whenever you use it, and within inside of inverse function determination, is if the resulting value equals x, then we would end up being an inverse of each other. So the way to do that, obviously, is what we just looked at in the last section, is to put the function of g into f. So putting g into f, we would get the following. And these would cancel each other, leaving us with x. So it checks off for that. Now we do golf. Now put function of f of x into g of x, and we're putting x plus 18 in for that x, and we get the following. These cancel each other again, leaving us with x. So these are, in fact, inverse of each other, right? Because they equal x. Thus, g of x is the inverse of the f of x. And that's all you're trying to determine. And you do this repeatedly. You put f into g and g into f and determine the value of whether or not it results in x. And if it does, then you are a function or inverse of each other. So This one right here is a inverse function of each other because they determine x as the output once you input f of x into g of x and g of x into f of x. All right, so you just follow this and you get to results of x. You are in fact an inverse of each other. Now, when we look at something like this, okay, the same thing applies. We're just going to go ahead and put g of x into f of x. And so we go ahead and look at the value of this in for the x. And notice the domain restriction, by the way. All right, so then we have this canceling each other. All right, and then we go ahead and get this. And then this is equal to this. Therefore, this fails, all right, to be inverse of each other. All right, this is going to give you some other value. This is not inverse of each other because it doesn't equal x. All right, that's all you have to determine is whether or not it equals x. And if it doesn't, after you simplify everything, then it's not an inverse of each other. Okay. Now you can continue that process, okay, for several different types of problems. Now, when you're graphing functions, all right, you can go ahead and graph the function. All right, this is x minus 6, so it's going to be the y-intercept of -6. So we're going to go ahead and do that, and the slope is up 1 over 1. All right. Now the inverse of that function would be obviously then to go ahead and determine what the inverse is. Now, I would say you can use the vertical line, or excuse me, the identity function, or switching of the coordinate points of x and y. However, they want us to go ahead and determine the inverse of it anyway. Now, the way you do that is a process where you take and represent f of x as y. All right, and then you switch x and y because that's what you're doing. Remember, you're switching x and y anyway, kind of thing. So you switch it and you solve back for y. That's how you determine the inverse. So then you go ahead and add 6 to both sides. You get y is equal to x plus 6. All right. So that's what we're looking for the inverse. And then all you got to do is switch the value of the y back to f -1 of x. I mean, and that's just notation. So that's how you do that. All right. So you have this, okay, equaling that, which we gave. And now we want to go ahead and graph that. So all you do is go up to +6. All right. And then we go ahead and graph it. It's up 1 over 1. And they look like they're parallel to each other. Okay. But that they should be because it's reflecting over the line of negative, x equals or y equals x. So the identity function. So we would have we'd have our answer. Okay. Oh, I didn't insert that. Of course, I didn't enter the answer there. But the answer isn't that x plus 6. Okay. So that's how you do this. So you just go ahead, put f of x to y, and then switch x and y and solve back for y, and then you get your inverse. Okay. So if I look at this one, then I would have simply doing this quickly. I would get this. I'm going to put the x first. X equals 2y plus 10. Go ahead and isolate for y. So I'm going to subtract 10 for both sides, divide both sides by 2, and I get my answer. So I would put the answer in as that. I would go ahead and say x minus 10 over 2. All right, so they have it as this. Watch, it should receive this as the answer. Okay, and I'm curious as to whether or not they do. They should, because it's in fact the same thing as this. All right. Now we want to, but when we're graphing it, okay, it's probably more appropriate that we graph it using this. So perhaps maybe you would want to go ahead and split it for that reason and that reason only. So you just take this 1 and divide it by 2, take this 10 and divide it by 2, and you get the value of 1/2 x minus 5, right? Now, I'm going to leave it as this answer, though. Okay, so now we're going to go ahead and graph this. So going up to positive 10, we're going to go up to over 1, and then going to negative 5, okay, negative 5, and then going down or up 1 over 2. And there we have our graph of our function. So up, it's not there. Disregard that one. It's not that I wanted to clear both of them. I mean, we got to go down to negative 5. So negative 5 up 1 over 2 is right there. I mean, then we go down, up 2 over 1. And that's better. Okay, I like that. That looks better. You can tell by just going ahead and looking at on a slant whether or not you did something wrong. And I knew I did something wrong right away when I was putting it in there. So now I'm going to submit all parts, and I get it that one right, and I must have done something. What did they want? It's negative. So that's right. So it's up 1 over 2. What did I do wrong? Did I do this one wrong? Up 2 over 1. I can't see where I graphed this one wrong. Do they want us to graph? Let me see the answer. Oh, that's what it is. They want us to graph the identity function. Where did it say that? Oh, okay, sketch the graph of the identity function. So they didn't ask us to do that on the last one. They did on this one. So, or did they? But anyway, I didn't read the instructions. Okay, they didn't make us do it on this one. Okay, or did they? Let me see. Oh, I would have gotten that one wrong too. Jeez, guys, apologize. So make sure you graph the identity function. So they're making us graph the identity function. So there's 2 parts I got wrong. I mean, well, first of all, I didn't put the answer in because I already showed the answer. But anyway, be sure to graph the identity function. All right, it's just getting to know the system and what it is the expectations are. Okay, so if we resubmit that, we get it right. Okay, just so make sure to identify the y equals x, the identity function. Okay, so good thing I went over that with you. Sorry that I didn't enter it the last time. I'm just going over the broad perspective of this, so I'm going a little too fast perhaps. So I'm going to slow it down a little bit. I got to, because otherwise I'm missing parts that it's asking for. So now we have 5 over 2, all right, x plus 10. We go ahead to solve for the inverse. We got that equation already, so that's not hard to graph. All right, let me graph that. So I'm going to go ahead. I can go to 10, but if I fall off the page, I can't graph the next part. So I can go down 5. Go down 5. 1, 2, 3, 4, 5, and go over 2. And that would be the same thing as me going up 5 over 2. So down 5 over to the left 2. Now I want to go ahead and find the inverse of this. Okay. And find the inverse, I want to go ahead and switch x and y. All right, switch x and y. So I got the y there. Now I want to solve back for the y. So I'm going to go ahead and subtract 10 for both sides. And then multiply both sides by 2/5. All right, so 5 goes into 10. 2 times 2 times 2 is 4. So I'm going to get that. So here's the inverse function. So I'm going to plug that in. So I get a fraction 2 over 5, and then x, and then minus 4. Okay. And then I'm going to go ahead and graph that one out. So down 4. All right. And then up 2 over 5. All right. And then I got to make sure I graph that stinking inverse function, or the inverse function. So there we go. See, and it really helps us identify that we look like we're symmetrical. I mean, perhaps that's why they go ahead and make us do it. But so finally, I'm starting to get them all right now. So make sure you go ahead and do what you're supposed to do. And I slowed it down a little bit to show you that, yes, I could do it. Okay. Don't you judge me. All right. Don't you judge me. It's not complicated. I know you think, oh man, I got to get it perfect in order for you to be confident in this. This is not about perfection. It's about understanding. So what it is that we need to do to make sure it's right for the system. So identity function, I got to follow all the instructions that are needed for it to be suffice, right? So learning from mistakes is good. Okay. So I'm going to do one more of these, and then I'm going to call it on this topic. All right, so we got this right here. Okay, so we have that function. Now this function right here is a cubic function. That mean, and if we remember translation, this is going to be a cubic function that's going to be 6 units to the right. So I want a cubic function that's 6 units to the right, and it looks like that. Okay, so I got that done. Now, because I want to throw this in here, I'm going to put this one right away. I want another inverse. I want the inverse function of that. And you know what? It's kind of crazy is that it's going to be a function that looks like a cubic root function at the value of 6. And it looks like that. I mean, but now we got to go ahead and come up with the cubic root function. So the way to do that is by switching the x and the y. And we can see we're going to need to take the cubic root of this side and the cubic root of this side in order to kill the third power. So then we're going to get y equals, and then we're going to add 6 to both sides. So it's going to be the cubic root of x plus 6. So now that's our answer for what we put here. Okay, so we're going to go ahead and put that in. We need a cubic root, so we're going to put that, push that from our palette, and then we're going to go ahead, put this, and then plus 6. All right, and now we have all the parts. All right, we've got all the parts in it. We're going to submit. All right, and we got that right now. Okay, so yeah, you can see now I'm being very consistent about getting it right because I'm not being too hasty. All right, being hasty isn't a good thing. It helps make a lot of mistakes. It does. So I'll let you have this for now on. Let me, you got the one-on-one relationship. There's one last thing I want to go over, and that is this part right here. Now I kind of already been doing it for you. This part is just taking the function that's given, all right, and then doing what we talked about already, and that is switching this to this, switching your x and the y, and solving back for x, or excuse me, solving back for y. So I'm going to go ahead and subtract 5 from both sides. And then, ironically, when we get this, okay, right here, the best way I do it is I take all of this and all of this and I switch them. That's how I do it. The fast way, just switch them and make it look like this. I copied the wrong thing. I said I'm switching them, and then I'm copying this part. Nope, copy this. All right, now I switched them. Now all I got to do is add 2 to both sides, and this goes away. So my answer could look like this. Also could look like some other version of it, but I'm going to put that as the answer. All right, so I have 3 over x minus 5 plus 2. All right, and then that's that one. Now I want to insert -3 into there. Well, -3 into there would be -3 minus 5 would be -8 plus 2, which 2 is the same thing as me saying, well, I want it to be basically 8, right? So it'd be same thing as me doing 16 over 8, because isn't that equal to 2? And then I'm going to go ahead and transfer this negative sign up to the numerator, not the denominator, because I can do that. And then I'm going to go ahead and get -3 plus 16 is positive 13 over 8. And that's the answer we're looking for there. All right, got that one right. All right, so I'm now entering into the system, right? So I went ahead and demonstrated the process of going and getting into the inverse and then substituting in a value for that. So you can now do that throughout a lot of these, okay? You want to use that process for it. Now this is a continuation and a reiteration of what it is that we've already been doing with domain, range of the function and its inverse, and that's all they're asking us to do here. So I'm going to let you have an opportunity to show understanding of this. I've given you lots of demonstrations of parts that are needed for this so you can be successful with this. So I'll leave that to you to complete and now be able to show that you understand what you're doing. I will stop this recording. Thank you.